Hi, I'm David and this is the Biology Classroom. In this video, I will explain about the Pearson's correlation coefficient and show you how to use it to solve a biology-related question. Pearson's correlation coefficient evaluates the linear relationship between two continuous variables which is normally distributed. When a scatter diagram indicates the possibility of a linear relationship, the coefficient can be used to describe both the strength and the direction of the relationship. The coefficient can be ranged from -1 to +1. A negative value shows a negative correlation, and a positive value indicates a positive correlation. 0 means that there is no correlation between the variables. The closer the coefficient is to -1 or 1, the stronger the linear relationship is. Now let's solve a problem involving Pearson's correlation coefficient. Let's say a researcher wants to find out if the different concentration of caffeine has different effect on a person's reaction time. He gives 10 subjects a different concentration of caffeine and measures their mean reaction time. He plots a graph of concentration of caffeine against the mean reaction time. The scatter diagram suggests that there may be a negative correlation between the two variables. So now he can use the Pearson's correlation coefficient to evaluate the strength of the correlation between the two variables. Firstly, we need to identify the null hypothesis. We assume that there is no correlation between them. So the null hypothesis sounds like this. There is no correlation between the concentration of caffeine and the mean reaction time. Secondly, we need to calculate the standard deviations for both of the variables by using this formula, where x is the individual data and x bar is the mean value. N is the size of the sample. Let's use x, the concentration of caffeine, to understand how to calculate the standard deviation. First of all, calculate the mean value, x bar. Then, find the difference between each of the individual data and the mean. After that, square all the values up and find the sum. You can now put the values into the formula. You will get the standard deviation. So we found out that the standard deviation of x is 64.08. By using the same formula, the standard deviation of y is 49.12. Step number 3, calculate the total of xy. Multiply each of the x with their y and sum the values up. Now we have all the data needed to calculate the Pearson's correlation coefficient. This is the formula. Fill in all of the values and you will find that r is equal to -0.864. This value indicates that there is a negative linear correlation between the variables. In other words, as the caffeine concentration increases, the reaction time decreases. But before we can make a valid conclusion, we need to use the table of critical values for Pearson's linear correlation test to find out the significance of this value. We usually use 95% of confidence level in a biostatistical test, so we will be looking at p equals to 0.05. df is the degree of freedom. It is calculated by the number of pair data minus 2. In this case, we have 10 pairs of data, so the degree of freedom is 8. The intersection of the degree of freedom and p equals to 0.05 is the critical value, so in our case, it is 0.632. Now we need to compare the calculated r with the critical r. Remember that we are using the calculated value without its negative sign, so we will only use 0.864. If r calculated is smaller than the critical r, the null hypothesis is accepted. If it is the opposite, then the null hypothesis is rejected. In our case, the calculated r is greater than the critical r, so we will reject the null hypothesis. It means that this value is significant enough to show the negative correlation. So the conclusion is that there is a negative correlation between the concentration of caffeine and the mean reaction time. If you enjoyed this video, don't forget to like, comment and subscribe. You can also follow me on Facebook. Thank you for watching and see you again soon.